Okay, now let us continue with question 3. Okay, we are asked to load the caravan dataset from ISRR package, so we just call the library again. Okay, and then in part A, we are asked to create training set which contains the first 1,000 observations. Normally, this type of choice is for our time series. Okay, because we want to take the old historical data, and then when we want to predict the future possibility, we take the earlier time and then set up the recent time as the thing we want to test. Okay, so let us just have a look at the dimension of the caravan. Oh, very large, right? Okay, so apparently we are actually using just no more than 20% of the data as training data set. Okay, and well, we have a lot of columns. Okay, but I mean, if we want to follow the question, the instruction is just something like this. Okay, so train 1 to 1000, and then okay, it's used as the training data set. Okay, so that's the solution for part A. Okay, now next, want to try to fit a bagging model to the training set with purchase as the response. Okay, so we know the formula has purchase here because of that, and other variables as predictors. So how do we know all the other variables? Hopefully you still remember the command call names, right? Okay, so we just have a look at it. Wow, a lot, right? Okay, so all this, and finally the last column is the purchase. And okay, so we are asked to use bagging model. So bagging sort of can be regarded as a special kind of random forest. So we load the random forest library, right? Okay, so yeah, I think you can see the messages coming out from random forest library. Okay, so the suppressed messages mentioned in practical 1, okay, can allow you to perform suppression of the messages. Okay, so based on what we've seen just now, I hope you understand why I have this thing. Okay, remember the caravan data actually has 86 columns. I only need so this is basically this part. Should I highlight it? This part is basically 86 minus 1, so only 85. So you can see P is 85. Right? Only 85 of them are for the features. Okay, so bagging basically just means set the M to be the number of columns which are used for features. Okay, so we just go ahead and run it, and it will probably take a while because think of it, is there how many 85 rows, 85 columns, not rows, 85 columns, and only just 1000, we are just using 1000 rows. Okay, so we are asked to fit the bagging model to training sets with purchase as the response and other variables as the predictor. So basically, yeah, very simple, right? Just 3 lines of commands and we achieve it. Okay, next we are asked to repeat by now using the random forest with a number of predictors is square root of p. Okay, so you see, that's why I set m to be equals square root of p, right? So what is m? Square root of 85, what should it be? Okay, you can see, okay, 85, right? So square root of 9 point something, isn't it? Okay, reasonable. Then we just pass this value to it. Okay, so random forest with only 9 columns. So we'll find that, okay, at home when you are actually working on this, you will discover this the time taken to calculate probably is going to be quicker compared to the bagging. Okay, this is random forest. Okay, should be faster than bagging. Okay, so yeah. They don't ask us to perform any prediction and other things. No, right? Okay, so yeah, okay. In that case, we can be a bit lazy. No need to create the confusion matrix, right? Okay, if you want to, then you have to take from question 1 some of the parts to do prediction from there. Okay, so next we're asked to repeat part B using boosting with 1000 trees. Okay, I'm a bit curious, how many trees random forest actually uses? Okay, apparently yeah, it doesn't quite keep the forest, so there's no way we can tell, right? Okay, so nothing I can say about how many trees are actually kept by random forest. Okay, so for boosting 1000 trees, boosting, the library we have been using is called GBM. Okay, then we start to do the seeding, and then the training we have to change. As I told you before, GBM requires the output to be numerical instead of categorical, so you need to if it's yes, you need to convert to 1, and if it's no, then convert to 0. Okay, similar for purchase. I mean the just now is training data set, this is the testing data set. Okay, but I think this thing probably doesn't matter because we haven't been asked to construct the confusion matrix, right? Okay. So boost caravan, this one uses what? Did he say we must use Bernoulli boosting method? Okay, so anyway, we can use the Bernoulli or the adaptive, right? Okay, so apparently it tells us that there are 2 variables without any variation. Okay, and from here can we see the importance of the variables? Okay, yeah, it tells us the importance of variables. Okay, based on okay, the importance measurement. So it's what? P per sort M core cloud more log. Okay, so that's for the Bernoulli distribution. Okay, yeah, here oh, this question did ask us to form a confusion matrix unlike the earlier ones, right? Okay, so yeah, okay, so let's just close the plot, and then we perform prediction. So the type is response. Okay, so this is the solution, right, to this one. Okay, all this, right. So this the construction of the model, then this is the prediction, and what's the predicted result? Okay, the output of course is probability, and here says that if the estimate probability of purchase is greater than 20%, that's why instead of using 0.5 by default, okay, now we are converting it to 0.2 because here the probability of purchase we are required just to be more than 20%. Okay, so after that we compare to the actual purchase to see the confusion matrix. Okay, it's not too bad, right? Okay, if we sum the diagonal of the confusion matrix, divide by okay, the size of the testing data set, okay, we find that wow, the accuracy is actually more than 90%. Amazing. Okay, then we are asked what fraction of people make a purchase in fact I mean, what fraction of people predicted, if you predict them to make a purchase, but they actually purchase. So basically you can find that this is the predicted, right? Okay, so it's okay, they are predicted to purchase, okay, but it's actually purchasing. So now let's see. Oh, it's actually very low. So despite the high accuracy, why is it high accuracy? It is because in this sort of model we find that a lot of people actually doesn't buy the thing. Okay, but if think about it, if you are marketing department and if you have done your prediction, okay, and what you're interested in is actually for people to know whether people will buy your product or not. So apparently in this particular case, okay, despite that we predict the people to actually buy the product, okay, but not only around 20% of the people would buy. So if your aim is actually to know how many people would actually buy your product, I think then this model is not really a good model, okay, because it gave poor precision. Okay, so then you have to consider other ways to retrain, okay, so that it will give you higher precision, okay, because in that case then you would know that, oh, when it predicts, it will tell you how many people actually would want to buy your product. Okay, and basically, have we solved everything? Yes, we have. Okay, the most complicated part is just question 3D, right? Okay, others are relatively simple because we are not asked to construct any confusion matrix. Okay, probably because you know that there will be lower accuracy